In this video, we're going to learn how to handle errors, transient errors in our LangGraph operations using something called the Retry Policy, using LangGraph's Retry Policy system. Now, imagine this. So you have a node. Let's say the graph that we are looking at, the hypothetical graph here, sends an email. So you have a node that collects user input and processes it, transforms it to a standard format. Then you have another node here that prepares the email. It drafts the email, probably even uses an LLM to draft the email. Then we have another node down here that sends the email. It sends it through a service, through a tool that calls an API. It's an asynchronous operation. It calls a remote service, sends an email. So we have from here to, and from here to here. So let's assume this does its operation, connects the user input, fine, everything works fine. This calls the LLM to draft the email. The email is drafted fine, everything is fantastic. Then when it gets here and is about to send the email, something goes wrong. You want to retry that. It tries to send the email through the service and it gets a 500 error. Something goes wrong. You want to be able to retry that, because API errors, especially the one that return a status code of 500, are transient. They are server errors, so you can handle them. It's not like 400 errors that you know that the problem is coming from you. You're sending a bad request, or you're not formatting the request in the proper way. But if it's a 500 error, you want to retry it, because there might be a network error, there might be some internet issue, there might be some database issue on the server backend and stuff like that, or just something on the network layer. So you want to retry it. And sometimes even the error might persist for a while, say a couple of seconds or like a minute. You want to keep retrying it. Retrying it, because you can't just leave it. You can't just leave it like that. The operation needs to continue. And this is an error. This is not a code error that it's there. You would have to go into the code to fix it. You can't be retrying a code error. You have to fix it before you retry it. This is something that occurred on the network layer that will be fixed. This is something that occurred probably at the database layer that would definitely pass away. So you want to retry. And that is why we have retry policies in LangGraph. And by adding these retry policies to your nodes, it helps your nodes to be resilient. It helps them to be reliable, so they can self-heal from issues. So if this node tries to send the email and the service fails, returns the 500 error, the node will automatically retry. Probably after like 2 seconds or after 4 seconds, it will retry. Then if it fails again, it will retry again. And you can always set the amount of time that you want it to retry using the retry policy. You can use the retry policy to set a lot of amazing things. You can use it to set how many times you want it to retry, how long between retries. You can even use it to set what errors it should retry on. So it's always good to get specific on the types of errors you want to retry on, especially when you don't just want to retry on every error, because like I said, for a code error, you have to go into the code to retry. So you can't have your system retrying an error when there's an error in the code. That will always fail, except the programmer goes inside and fixes that error. But if it's a transient error, mostly network, it might even be when you're calling the LLM, OpenAI service can fail, Gemini service can fail. You want to retry those kind of errors. And so you can also set errors. You can even define something called a backoff strategy. That kind of expands the timing between each retry. So if you retry after 2 seconds, the next retry can be after 4 seconds. Then the next one can be after 8 seconds. So you kind of define like a multiplier to either increase the time exponentially or constantly. So how do you retry? How do you configure a retry policy? So like I said, a retry policy first has to be done on a node. And if you want to set a retry policy, but let me put this aside. Let's get this aside. Yeah, just stay here. So if you want to set a retry policy on a node, let's say you define your node. Say my node, and it takes in the state and all the yada yada yada. Define it. Then so you have your node. You set your retry policy when you want to add the node. So let's say we have builder, state graph, takes in the state schema. Then when you want to add your node, say add node. You set your node name. You set your node function. Then for your retry policy, you set a retry policy argument. Retry policy argument. And you set it to the retry policy class. Retry policy class. Okay, put it here. So you set it to the retry policy class. You set a retry policy argument and set it equal to retry policy class. Now this retry policy class can take a bunch of values. It can take a bunch of arguments rather that you can use to configure it. Like I said, you can configure how many times you want it to retry. You can configure the distance or the time between each retry. If you use it this way, it's just going to go with the defaults, which are also good, but sometimes you want to have more control. So let us look at this. Let us look at the retry policy class. I'm just going to put this here. Let's say retry policy and look at some of the arguments that it takes inside its constructor. So retry policy, let's go inside there. One of the most important ones is max attempt, or most common ones is max attempt. It's of type integer, though you don't need to set it like this. You don't need to set it this way. You just said max attempt. But you also know that it's of type integer, and you said to how many times you want it to attempt a retry. How many times you want to attempt a retry? Because you don't want to retry forever. You don't want to retry forever. So you can say like 5. 5 times is good. If you tried 5 times and it's not going through, just raise an error. Just raise an error, and you find out to gracefully address the error. Another one is initial interval. Initial interval. And this is seconds. This is in seconds. And it sets how long you should wait before the first retry. Yeah, how long you should wait before the first retry. So you can say once it happens, just wait like 2 seconds first. Yeah, wait 2 seconds first. Then subsequently, probably you can do like one second after that. So that's the initial interval. You can also set a back-off factor, something called a back-off factor. Now your back-off factor is also of the type float. By the way, initial interval is also of the type float. Let me just put that here. Okay. So this is int. This is float. Okay. So back-off factor is also of the type float and is a multiplier for the interval timing. So if you set it as, let's say 2, if you set it as 2, if the initial interval is 2, the next interval will be times 2, so that will be 4. The next interval after that is going to be 4 times 2, which is 8. The next interval after that is going to be 16. That's 8 times 2. So it's kind of like expanding the time that you want to be between each retry. It's expanding time between each retry, because some transient errors can actually take a while. So you don't just want to be retrying after like every 2 seconds, and it will just kind of hit some rate limits. So you want to be spacing out the time, so that you don't DDoS there, or should I say DOS, because it's not distributed. So yeah, the back of is cool, and it's also a float, so you can set it to like 1.5. So back off is a float. Let me put this comma here before putting this. Back off is a float. The next one we're also going to look at is called max interval. Max interval. Now you can set back off, but sometimes you probably don't want it to keep increasing to like let's say 500 seconds or to like 10 minutes. So you want to say, okay, no matter the amount of multiplication that is going on the interval between each retry, it should not be more than 128 seconds. So it's also in seconds. It should not be more than 128 seconds. If it reaches 128 seconds, they just be retrying after every 128 seconds within the number of attempts. All this is still within the number of attempts. So it's not like it's going to go on forever. So this is an int. This is an int. Or it's a float. Sorry. It's a float. It's a float. The next one is jitter, which is quite interesting. It's a Boolean is a Boolean field, so you can set it to true or false. It's equals. So jitter is Boolean. You can set that to true or false. And what jitter does is that it just kind of randomizes the timing. So even if you have a multiplier that's like 2, and let's say you multiply 2, the initial interval is 2, so then you have a backup factor of 2. So you say 2 times 2, that's 4. But instead of doing it at 4, it can decide to do it at 4.2 or 4.8. Just kind of stagger the time so that in case you have like multiple nodes that are working with that retry policy, they will not be firing at the same time. They will not be firing at the same time. They will not be trying to retry at the same time. And this is quite important, especially in production, because you want to avoid something called a thundering herd. You don't want like multiple nodes to just be firing at the same time, retrying at the same time. No, you want to stagger them so that they all kind of have like a few gaps between when they are retrying and everything doesn't like raise hell. So we have jitter, and finally we have the retry. Let me put this here. We have the retry on argument. And what this does is that it just sets the errors you want to retry on. It sets the errors you want to retry on. Now you can decide to retry on all errors, so you can just say exception and it will retry on all errors. This is not advisable. Like I said, you don't want to be retrying on errors that you need to manually fix. You want to retry on errors that are transient. Like I said, I always say API errors, network errors, database errors. You want to stick to transient errors. So this is not advisable. So you can also retry on specific errors, Let's say a timeout error. You can say I want to retry on a timeout error. So you can pick a specific error and retry on that error. If you want to retry on multiple errors, then you would need to use a tuple. So let's say I want to retry on timeout errors. I also want to retry on connection errors. And I want to retry on rate limit errors, which are all transient. So I can say, yeah, I want to retry on this set of errors. So these are you retry on multiple errors. You can also retry on custom errors from packages. Like, for example, SQLite. If you import SQLite and there's a specific SQLite error you need to retry on, you can simply just say SQLite 3 dot, and you can say I want to retry on the operational error. So when I get any operational error, let's say your node is trying to access an SQLite database, you can say you want to retry on this particular error. And anytime this error occurs, it is going to retry the operation in the node, the query that you're sending to your database, or the connection that you're trying to make to your database inside that node. So that's the amazing retry policy. And next, we are going to look at an interesting example in VS Code. So now that we've learned the theory of retry policies, let us see them in action. We're going to write a simple graph that makes requests to a mock weather API. We're going to write the code in a way that it's the request has a 70% chance of failing, and we'll see how our system retries it until it gets a successful result. So let's start. I'm going to create a new file, and I'm going to call that retry policy demo.py. Inside our file, let's start by importing our dependencies. So from typing, let us get typed dict. Then from LangGraph.graph, let's get our graph tools. So import, dict graph start and end. Then we also need our retry policy. Say from LangGraph, that should be types, import retry policy. Good. Retry policy. Then we're also going to import the random package from the standard library. for some of the mock error simulations that we're going to be doing. So let's get that in place. Next, let us create our schema. I'm going to call it weather state. Weather state is a typed text, and it's going to have 3 state keys, 3 state variables. The first is going to be the city, for which we want to check the weather, so that'll be a string. Then we have temperature, which is just part of the weather information we want to get. That will be a float. And then we have conditions, which is just the weather condition, like sunny, cloudy, and stuff like that. So we have this in place. Next, we're going to create a mock class for our API error. So just create a mock exception. We're not going to do anything inside. We're just going to pass. Put some comment here and say simulated error. So this error we're going to raise, and this error we're also going to listen on our retry policy. So we create that, and the next thing we're going to do is to create the node that is going to help us fetch our weather information. And this is the node that is going to try the API, and we'll make it in a way that it has a 70% chance of failing. So let's say fetch weather. Let's go to fetch weather state, weather state. Good. Get weather state. Good. So the first thing we do, let's get our city. Our city, and then let us simulate our requests. So simulate request. We're not going to be making an actual request. We're just going to say that if random.random is less than 0.7. So anytime it falls below 0.7, we assume that it fails. That's the 70% chance of failing I was talking about. So just assume that it failed. Now inside here, we're going to print. Say f string, we'll print a message. I finally figured out to use emojis in VS Code, so I'm going to put in that here. So I'll say f string, and here we'll just say API call failed for our city. Failed for our city. Then what we're going to do here, we're going to raise our API error. Raise API error, and just say weather API timeout for city. Yeah, weather API timeout for city. So we have that. Let me put a big X here. Yeah, and put a big X here. Okay, should have failed. Now let's undo the success situation. Let's say I don't need to put an else self. Let's just undo the success here. I'm going to say print, and here I'm going to say successfully fetched weather for city. Then we'll just get a mock temperature, call it, say random.uniform. So we can pick within this range and inclusive of the numbers. Put one here. Then for conditions, we can just say random.choice and give it a list to pick from. So here we can say sunny, cloudy, rainy, partially cloudy. Okay, so those are the conditions. That's the temperature, and we're simply going to return both of them back to the state. So temperature is going to be temp. Conditions is going to be conditions. Okay, so that's good. We've set that up. If it fails, if it gives us any random number or random float number less than 0.7, it will just raise this API error and print this. So let's put that there. I need to get out of this function actually. Come down. Good. Now next we're going to create a node that brings all this information together and just presents the weather information. This might be something that you want to do for like a widget, a weather widget. So it just formats the whole thing, adds all the icons and stuff like that, and it just presents the information. But yeah, we're just going to be printing stuff out. So I'm going to say format result, say state. I'll set that to weather state. Inside here, we're going to format stuff. So first I'm going to print F, I didn't put the brackets. So F string, new line, and we'll say weather. Yes, I want an emoji here, so I'm going to just come here. I think I should have that here. Emoji, so I'll put it here. Yeah, this will be cool. So yeah, we'll say weather report for, we'll get a city. Yeah, weather report for city. I'll say print, and for temperature, going to say state temperature, and yeah, say here, right? Yeah, degrees. Then the next thing we're going to print out is the weather conditions. Print conditions, and I'm going to say state conditions. I'm not changing anything in state, so I'm just going to return it back. Good. Let me do something here. Let me change this X to an emoji. Just go here, emoji. So let's make this a proper X, and if it's successful, let's have an emoji here, and that should be, yeah, check mark. Okay, just to beautify the output. So let's put that here. Going to get out of this function. Good. So now we have our nodes, and we can start building. So say builder equals state graph, and we put weather states. State graph weather states. Then we can add our nodes. Without our add node, I'm just going to be dumping the functions directly inside because I want to give them the same names as the function names. So fetch weather and format result. Now, fetch weather is where we're going to set our retry policy, because that is the one that is performing the fetch operation, the asynchronous fetch operation that we are mocking here. So we want to make sure that whenever it fails, because we've already set it up to fail 70% of the time, or have like 70% chance of failing, we want to make sure that when it fails, we retry. So let us do that. So I'm just going to come here. Let's do this like this. Let me just do this the proper way. Put the name. Let's come down here. Put the name. Add the function. Be a good boy. Then say retry policy. So we set the retry policy argument. And like I said, we set this to retry policy, the class. And then inside the constructor, we can configure it. So first, we want to give it max attempts. Leave that at 5. After 5 times, it's just fail. 5, then initial interval. Let's set that to 1 second. Let's give it a back off factor. Back off factor of 2 is okay. 2.0. The max interval should not be more than 10 seconds. And let it jitter. Set that to true. And very important, it should retry on our API error. It should retry on our API error. So it should retry when our API error is raised. So I have that in place. Set that up because this is the node where the main action is taking place, and we want to retry whenever it fails. So next, let us add our edges. Say builder dot add edge. We start. We go to our fetch weather node. Then I'm just going to copy this a few times. Then from our fetch weather node, nope, not that. From our fetch weather node, we go to our format result node. Then from our format result node, we end. So I don't need that last one. So end everything here. So that's good. Now we can compile our graph by calling the compile method. And now we can test the graph. So just going to say test the graph. That's the graph. And we're going to be testing this graph. We're going to be wrapping it in a try except block because we might exhaust all the attempts. And once we exhaust all the attempts, we just want it to feel like a normal error. So we're going to be wrapping this around a try except block. So we're just going to say result equals graph.invoke. Then we pass in our initial state. I'm just passing it this way. Pass in our initial state. And for that, we'll say our city should be San Francisco. The temperature should start at 0. And the conditions should just be an empty string. And down here, we can print. Say f string, new line, final result. And since I'm now addicted to emojis, I'm going to put a sparkle here. Yup, just for the flair. Then if we exhaust our attempts, then we just catch it as an exception. Down here, we can say print, new line, another cool emoji to show that everything blew up. And then we can say all retry attempt exhausted. And just talk about the error. Print out the error. Okay. So everything is in place. I think we can run our graph now. With our node, our fetch weather node, having this retry policy. Now when we run our graph, the number of times this message shows up, this API call failed for city shows up, shows us the number of times it failed. And we'll see that it will be retrying. So we're going to run it a couple of times just to see what it does in different at different times. So the Python retry policy demo. Let's hope everything works fine. Hit enter. So it failed, then it succeeded. It failed, it retried, then it succeeded. That's not fun enough. Let's try again. I want to fail a couple of times. Oh, this one just succeeded once. That is no fun at all. Let's try again. Fail. Good. Now we're talking. So you see, the time between each failure is expanding, and this has gotten to 4. If it fails one more time, it's not going to retry again. So it's still all attempts exhausted. All attempts exhausted. Now we might have tried this a lot of times. I would never hit this. So it tried 5 times, and you see the gap between each retry was getting bigger because of that backup factor. And at the end of the day, it retried all the time, and yeah, we exhausted our attempts. And you see, and this now it's succeeded once, failed once, failed again, succeeded. Awesome. That was cool. So yeah, that's how you use retry policies in LangGraph.